All right, we are going to get into Ecell under non-standard conditions. So we're talking about galvanic cells still. Remember, a galvanic cell is where we have two different electrodes placed in two different solutions. There's an anode and a cathode. The anode is where oxidation occurs. The cathode is where reduction occurs. Anox, red cat. Flow of electrons is from the anode to the cathode, fat cat. And remember, they're connected by a salt bridge to control, make sure the charge doesn't, or balance the charge. So in this case, we have zinc plus gold ions yielding zinc ions plus gold metal. So the zinc is being oxidized, so it's at the anode, and the gold is being reduced, so it's at the cathode. Okay, and I found the reduction potentials and oxidation. I flipped the one for zinc, and I got 2.45 for Ecell. Notice this is standard because they're 1 molar solutions. So we call this Ecell E naught. We add the little degree sign. That means it's under standard conditions. But what happens if I change the concentration? So let's say I make the gold ions 0.5 and keep the zinc ions at 1.0. What we do, some of you may be thinking that, well, we could just use Le Chatelier's principle and talk about how it shifts left to right. But since this is not an equilibrium, we can't use that. So what we have to do is use Q. Okay, so we set up a Q expression, reaction quotient expression, with our product over our reactant. So it's 0.1 over 0.5 squared, which will give me 4. Well, if you think about back up here, our reaction quotient is 1 over 1, which would just be 1. So if we compare this 4 to the initial, which is 1, our reaction quotient is going to our reaction quotient will decrease because Q is getting bigger. So reaction quotient, or I mean our Ecell decreases because Q is bigger than our original Q. If in this case we have 1.5 molar Au plus, 1 molar zinc 2 plus, so this is our reaction quotient here. It's 0.44. Again, compare that to original Q, then Ecell is going to increase. Because it's smaller, it's got to go to the right, and it will increase. Now, one thing that we're using, the concept is based on the Nernst equation. Which is E equals E naught minus RT NF ln of Q. Okay, so in this case you have the E with that's non-standard equals the E standard minus RT, the gas constant, or the universal gas constant, temperature, the moles of electrons, and Faraday's constant, which we'll get to later, times the ln of your Q that you calculated. So you're not going to need to calculate anything with this, but you just kind of need to know that this is what we're using to kind of get to our E under standard conditions, non-standard conditions. One other thing I wanted to point out is when our reaction We think about a dead battery, right? What is a dead battery? What has happened that our battery has died? Our voltage becomes zero when our battery dies, right? Whether it be a car battery, a phone battery, a battery in a flashlight, anything you'd use a battery for. What happens? Our voltage becomes zero, but why does our voltage become zero? What happens is our reaction has reached equilibrium. So this flow of electrons is constantly happening, right? But once we get a buildup of the product, eventually we're going to start going back the other way. The reverse reaction is going to start going. And what happens at equilibrium? You remember the forward reaction, the rate of the forward reaction, the rate of the reverse reaction are equal. So those electrons are still flowing, but there's an opposite flow, a reverse flow, that is equal to that. So the total net flow of electrons is zero. So we're getting these electrons flowing, but they're also flowing back the other way. So our light bulb goes out, our phone dies, our car dies, whatever. And in the case of your phone, you can recharge that. So we plug it into the wall, and what happens? It reverses that reaction.
Teacher, this is just a reminder. Please stop by the.
So yeah, that's our reaction has reached equilibrium when the battery is dead. Okay, or that's what causes a dead battery. It's not that the reaction has stopped; it's just that it's reached equilibrium. So let me know if you have any questions, and we'll see you later.